Yeah, we're gonna do 7.5 today. So y'all, just before we get started, I did send you guys an announcement through Blackboard today. I know I don't usually send announcements through Blackboard since it's an in-person class, but I did send you one. And I just took a screenshot of it from my iPad and I sent it to you guys on Pronto too. But just to let you know, guys, Friday, November the 12th, which is not this Friday, but next Friday, that's the last day to withdraw, okay? So I think you guys are here. I think y'all are doing really well. I don't think anybody's in danger of failing or anything like that. But off the top of my head, I don't know everybody's grades, but I think a lot of you guys are doing pretty well. But if you're not certain, when you sign into Alex, y'all definitely click on the gradebook feature so you can see what your overall average is. Okay, so if you're doing all right, I mean, if you're passing, if you got a 70 or better, then you're probably good. Even if you're in the 60s range, you're probably okay. But if you're like, I don't know, I'd say like 66 or better, you're probably okay. You still have a shot at it. But if you're like at 59.7 or something, then you might want to consider, hey, do I need a bail before November the 12th? But anyway, in case I put some guidelines in what you need to do. So the colleges, I don't know, they're a little funky about you all withdrawing. So before anybody withdraws, they contact admissions. Like if you're going to withdraw any class, not necessarily just this one, you contact admissions and they say, well, you know what, you need permission from your instructor to withdraw. For whatever reason, that's what you're doing. I don't know. But anybody who's contacted me saying, sir, I want to withdraw, but admission says you need to okay it, I always okay. You know what I mean? I never say, no, you can't withdraw. Right? I don't know why they do, you know what I mean? I think one of the things is sometimes people are like, well, I have a 68, I'm failing, right? And some people are like, to me, if you have a 68, I would hope that at that point, you would know enough to say, hey, you know what, I have a good shot of doing it, but apparently there's some folks that don't, you know what I mean? So anyway, but if you, on November the 12th, which again is not this coming Friday, but the following Friday, that day you don't need to talk with your instructor about anything. You can just go and contact admissions and just let them know. And I did put an email address right here, y'all, for the admissions folks. Just let them know that that's what you're wanting to do, huh? Okay. Yeah, so anyway, I just kind of wanted to go through that, y'all, just to let you know about it. But like I said, I think you guys are doing okay. But if you're uncertain, you can send me a message privately on Pronto, or you can message me through Blackboard. Pronto is probably better, guys, because I see those immediately right on my iPad. I told y'all before, and I can double check for you and show you how you can figure out your grade. But I just wanted to kind of go through that first. All right, so let's see. Let me get back to what we're doing today. So where are we? Where's my weekly activities folder? We're right here. And so we're in week 11, y'all. And so today we're going to cover 7.5. So let me access that here. It is, download it, and here we go. Let me send it to OneNote. Let me get my OneNote going first, y'all. And then we'll get started. Let's see, that's from my other class that I had yesterday. Uh-huh. Oh. And that's what we're going to do today. Yeah. And you know what? I hadn't thought about it before, but I know that the graphing calculator will do. I'm pretty confident it'll do dot products. I don't remember though off the top of my head though, John, how to do it on the calculator, but it's a pretty straightforward process. So you're going to see today, y'all, when we go through this. Let me scroll back down here. There we go. It's coming up right here. Here we go. This is us. Okay, so again, I want to just double check. So that's not what I want to do. I don't want to click the wrong thing. Okay, that's fine. And let's get rid of that because we don't need it. Okay, let me come back over here. And let's see, I thought I was sharing the screen. Apparently I'm not. Okay, now we're sharing the screen. All right, so I'm glad I double checked. Oh, are we recording too? Yeah, here we go. Okay. All right, so let's see. 7.5, y'all, is talks a little bit about dot products. Okay, so let's figure out what a dot product is. Let me get my pen going here. Okay, so compute dot product. So it says the definition of a dot product, if we have a vector V that has components A1 and B1, and we got a vector W that has components A2 and B2, then the dot product is defined as A1 times A2 plus B1 plus B2. So the dot product, y'all, is going to give us a scalar, meaning it's just going to give us a value. It's not going to be a vector, so we're not going to have two components, because with the vectors that we're dealing with here, y'all, we're dealing with vectors in 2 dimensions. But again, I know some of you said, you told me what your majors were, so I said some of you guys are going to end up taking like Cal 1, Cal 2, Cal 3. Guys, I remember when I was a student, when I saw vectors, I remember seeing them in Calculus 3, and we did like 3-dimensional vectors, and we even did 4th-dimensional vectors, and then we would do something that's called n-dimensional vectors, right? So it's in multiple dimensions, okay? All right, so anywho, let's go ahead and see if we can't figure out some of these dot products. So the first one here says we want to compute the dot product of V and W. So the way we're going to do this one here, y'all, I'm just going to use this formula, A1 times A2 plus B1 times B2. Okay, so remember, this is my A1 and my B1, and this is my A2 and my B2. So we're going to take negative 2 times 3 plus 2 times 14, and this is going to give me a negative 6 plus 28. Anybody know what's negative 6 plus 28? I owe you $6, I got 28. If I owe you $6 and I have 28, 22, right? Yeah, no, we're good. We're good. You multiply each of the individual components, and then we add them together. Okay, so now let's go ahead and do the second one, right? So it's V dot B. So y'all, look what we're going to do. Because it's V dot B, we're going to take A1 times A1 plus B1 B1, right? Because we're taking the same vector. We're taking the dot product of the vector with itself. So we're going to have negative 2 times negative 2 plus 2 times 2. So negative 2 times negative 2 is a positive 4. 2 times 2 is 4. 4 and 4 is 8, right? Okay, and then we're going to do one more with the dot product of W with itself. Okay, so again, I'm just going to use this formula right here, y'all, because I'm doing the vector with the dot product of W with itself. I'm going to sort of write it like this: A2 times A2 plus B2 times another B2. Does that make sense? Okay, so let's go ahead and do that. So we're going to take 3 times 3 plus 14 times 14. Oh, I know that's 9. What's 14 squared? That's what we got our calculator. So say 14 squared is 196. And 9 plus 196 should be something like 205. There we go. Okay, so we know how to compute a dot product, right? Okay, so let's take a look here, and it says properties of dot product. So if U, V, and W are vectors, and C is a scalar, then the dot product of V and U is the same thing as the dot product of W and V. Okay, so all that means is it's commutative. Okay, you can switch the order, and it doesn't really make any difference. If you have a scalar times V, and you're going to take the dot product with W, you can find the dot product of V and W, and then just multiply it by that scalar. Okay. If we have U plus W, we're going to find the sum of those vectors, and then we're going to do the dot product of that. Then we can find the dot product of V and W and add the dot product of V and U. The dot product of a vector with itself is the same thing as magnitude squared. 0 times the vector V is just going to give me 0, or the dot product. And then again, the dot product of v and w times the scalar of c can be written as the scalar with v with the dot product of w, or v with the dot product of c and w. Okay. So let's see if we can figure out this next part here. It says find the angle between two vectors. It says given two vectors v and w in standard position. Let's see. The angle theta between v and w is the angle formed by the two line segments representing v and w, where theta is between 0 and 180. Okay, so a couple of things are important here. My angle should be between 0 and 180, right? And this is how we're going to find the angle between the two vectors. Okay, so let's take a look here. Let's see if we can figure this one out. And I'm just going to zoom up a little bit so I got a little bit of room here. But it says find the angle between the vectors v and w. Okay, so the first thing I'm going to do, y'all, I'm going to write down the formula. Cosine of theta is equal to the dot product of v and w divided by the magnitude of v and the magnitude of w. Okay. All right, so first thing I'm going to do, y'all, let's find the dot product of v and w. Okay. So remember, the way we're going to do the dot product, y'all, is we can think of the vector v. Right now it's in the form, it's in the ai plus bj form, right? So we can write it in its component form like this, -2 and 3. And we can do the same thing for w. We can write it in its component form, and we'll write it as 3 and 4. Okay. All right, so again, I know this is my A1 and that's my B1, and this is my A2 and this is my B2. So remember, y'all, the formula is A1 times A2 plus B1 times B2. So we're going to take -2 times 3 plus 3 times 4. So that's going to be -6 plus 12, -6 plus 12. Everybody agree it's just 6? All right, so we got that part. Now we need to find the magnitude of v. So remember how we find the magnitude of v? We're going to take each of the individual components, we're going to square them, we're going to add them together. It's kind of like the Pythagorean theorem, right? So I'm going to take -2 squared plus 3 squared. So the magnitude of v, let's see, -2 when we square it is 4, 3 squared when we square it is 9. So 4 and 9 should give us 13. Okay. And we got to do the same thing. We got to find the magnitude of w. So let's do that. Okay, so w is, this is going to be 3 squared plus 4 squared. 3 squared is 9, and 4 squared is 16. And so 9 and 16, anybody know? Yeah, 9 plus 16. 25, and the square root of 25? It's just 5, right? Okay. So check it out. Look, we found the magnitude of v. We found the magnitude of w. And we found their dot product. Okay. So over here on the side, y'all, I'm just going to write, look, cosine of theta is equal to the dot product, which was 6, divided by the square root of 13 times 5. I'm going to write like this. Cosine of theta equals 6, 5 root 13. And so remember, how do we find the angle? We got to take the cosine inverse, right? So we're going to say theta is the cosine inverse of 6 over 5 root 13. Now, y'all, normally when we were, throughout the whole semester, we've been talking about what happens when I have a radical on the bottom. We talk about, we got to rationalize the denominator, right? Since I'm going to be using my calculator here, y'all, I don't need to worry about that. You know what I mean? If I was going to write a final answer and I had a radical on the bottom, then I would worry about rationalizing. But because I'm looking for the angle here, I'm not going to necessarily do. I'm just going to go ahead and punch this in, right? So first thing I'm going to do, get my calculator going. I want to make sure I'm in degree mode. Right now I'm not. So let me put it back in degree mode. There we go. Okay, so we're going to go second cosine inverse, and I'm going to type in all that business there, y'all. So I'm going to put 6 divided by. Now, on my calculator, I want to make sure that I'm dividing by all of that, okay? So the way I'm going to make sure that I'm dividing by the whole thing, I'm going to put the whole bottom, y'all, in parentheses. So I'm going to do 5 square root of 13, close it off, and I think I need to put one more parenthesis to close. And I'm going to hit enter. And hey, take a look here. We came up with our angle theta, 70.559. Are they asking me to round to a particular decimal point? Yeah. I'm sorry? Oh, the whole problem? Yeah. Like zoom out? Is that what you said? Yeah. So far I'm good, John? Okay. All right, just double checking with you. All right, so guys, we're going to go to one decimal place, 78.5, 78.6. We don't think. 0.6, right? Okay, good. So theta equals 70.6 degrees. And remember what we had here, y'all? I'm going to kind of zoom back out a little bit. My angle needs to be between 0 and 180 because obviously we're talking about the angle inside of a triangle, right? And you know that the sums can add up to more than 180 degrees. And so, here's our all right. John, am I good? Okay, just double checking. Okay, so let's take a look here, y'all. And I'm just going to zoom in a little bit here so I can see this a little bit better. Okay, so it says the cosine of our angle theta is equal to the dot product divided by the magnitude of V and the magnitude of W. Can also be written as dot product of V and W is the same thing as the magnitude of V times the magnitude of W times the cosine of the angle. Okay, so let's take a look here. It says if our dot product, there's a couple of things we got going on here. If the dot product is greater than 0, remember all that means, y'all, is that my dot product is going to be positive. Okay, so let me write that here just so that we understand. That means it's going to be positive. If the dot product is positive, then the cosine of my angle is positive, and that's telling me that my angle is going to be between 0 and 90. Okay? If our dot product is less than 0, y'all, means it's going to be negative. Okay? And so if the dot product is negative, then the cosine of our angle is negative, and that's telling us that our angle is going to be between 90 and 180. Okay? All right. Then the other part we got here, it says if the dot product is equal to 0, here we go. If the dot product is equal to 0, then the cosine of our angle is equal to 0, and so our angle is going to be 90 degrees. Okay. So if the angle between the two vectors, y'all, are 90, then we say that V and W are what we call orthogonal angles. Okay. That just means that the angle formed between the two vectors is 90 degrees. Yes. Yeah, like that, right? Like a corner. You're right. Okay, so it says two vectors V and W are orthogonal if and only if the dot product is equal to 0. Okay, and then our vectors are going to be parallel if the dot product of the vectors is equal to the magnitude of the first vector times the magnitude of the second vector, or if the dot product of the vectors is equal to the negative magnitude of the first vector times the second vector. Okay, so let's see if we can figure this out. What are we trying to do? Okay, so it says determine if the given vectors are orthogonal, parallel, or neither. Okay, so look what it says. They're going to be orthogonal if their dot product is 0. And they're going to be parallel if the dot product is equal to the magnitude of the two vectors multiplied, or the opposite of the magnitude of the two vectors multiplied, okay? So, in either way, y'all, we got to find the dot product. So let's find the dot product of K and S. Remember, this is my A1, this is my B1, right? This is my A2, this is my B2. So if we're going to find the dot product, then we're going to take 1.8 times -9 plus 0.3 times -1.5. Okay, so I'm going to just take my calculator right here. Let me turn it on. 1.8 times -9, -16.2. Okay, and then we have to do 0.3 times -1.5. 0.3 times -1.5, and that's a -0.45. And so we're going to add those two numbers together. 16.2 negative plus our answer that we got from the previous problem. And I'm coming up with a -16.245. Okay. So -16.245. Okay, so first question. Are the two vectors orthogonal? No, right? Because the dot product would have to be equal to 0. Okay, so I know they're not orthogonal. So now, John, am I good? Did you come up with the same number? Did you come up with a -16.245? Because did you come up with a 0.045? Okay, did you take 0.3? You know what? My mistake. Look, I put 0.0. That's my bad. 0.3 times -1.5. You're right, John. I'm wrong here. 0.45, right? That's what you got. But for the second one, John, you got point. Okay, you did it on your calculator. Okay. All right. So you came up with -16.65. Okay, you're right. That was my mistake. I just entered it wrong on my calculator. So, guys, I make boo-boos too. Okay, so let's take a look here. We know that they're not orthogonal because in order for them to be orthogonal, their dot product would have to be equal to 0. And we didn't get 0. We got -16.65. Okay, so now we got to check to see maybe it's possible that they're going to be parallel. So this is how we're going to find out if they're parallel. We're going to find the magnitude of V and the magnitude of W. We're going to multiply them together, okay? And if we get the same value or we get the opposite value, then those vectors are going to be parallel. So look, let's do this. Let's find the magnitude of V. Okay. So the magnitude of V is going to be 1.8 squared plus 0.3 squared. Okay. So, oops, and then we're going to take the square root of that. So I'm going to take 1.8 squared plus 0.3 squared, hit enter, and I'm going to take the square root of that. And wow, I'm coming up with a whole bunch of funky stuff. So y'all, I'm going to keep this as the square root of 3.33. We're trying to find, so remember what it said? It said if they are, we already knew they weren't orthogonal, right? So in order for us to figure out if they're parallel, John, we got to find the magnitude of V and the magnitude of W, multiply them together. If we get the same thing that we got as our dot product, or if it's the opposite number as the dot product, then they'll be orthogonal. So I'm finding the magnitude of V, and now I'm going to find the magnitude of W, and I'm going to multiply them together. K and S. I'm sorry. Yeah. Yeah. My bad. I see what you mean. Yeah. I was going to be in W because of the way it was written, right? Okay, so let's find the magnitude of S now. So the magnitude of S is going to be equal to the square root of, what, negative 9 squared plus negative 1.5 squared. Okay, so let's go like this. Negative 9 squared plus negative 1.5 squared equals that, and I'm going to have that in the square root as well, right? So 83.25. So far, are we okay? John, do you get the same number? You get the square root of 83.25? And you got the square root of 3.33? Okay, they gave you that 1.8 with a whole bunch of decimals and stuff like that? Okay, so look, the only reason I'm writing it this way, John, is because if I do the 1.8, then I'm going to have to do some rounding somewhere. You know what I mean? So that's why I'm writing it that way. Okay, okay, that's fine. Now, look what we're going to do, y'all. We're going to multiply those two numbers together. So on my calculator, I'm going to take the square root of 3.33 times the square root of 83.25. Okay, and I'm going to hit enter, and look at the number that I'm coming up with. On my calculator, y'all, I'm coming up with 16.65. So, right, so when we take the magnitude of K times the magnitude of S, we came up with 16.65, right? Now, I want you to look at this number here, and I want you to look at the dot product. They're not exactly the same, but they are opposites of each other, right? That's exactly what this part here says. It says they're either going to be the same, or one's going to be positive, one's going to be negative. And as long as the values are the same, or you could say the absolute value of each of them have to be the same, then those vectors are going to be what? Parallel. Does that make sense? So for number 3, y'all, what I would say is at this, after we've gone through all of that business, we're going to say these vectors are parallel. All right, so let's try number 4. We're going to go about number 4, y'all, doing exactly the same thing. Okay, so the first one we're going to do, it looks like we have our vectors B and A. And so the first thing I'm going to do, y'all, I'm going to write them in component form. So B is the vector, what, 2/3 and negative 12. And A is the vector 15 and 5/6. Okay. And so we want to find, the first thing we want to find is we want to find the dot product of B and A. So we're going to take 2/3 times 15. I'm going to think of that as 15 over 1. And we're going to add negative 12. I'll think of that over 1 times 5 over 6. So the dot product of B and A, let's see. First thing, y'all, 3 goes into 15 times. And so 2 times 5 is going to give me 10. And 6 goes into negative 12, negative 2 times. Negative 2 times 5 gives me a negative 10. And 10 minus 10 is 0. So remember what we said. I'm going to come back over here, y'all. The two vectors are going to be orthogonal, which means that the angle formed between them is 90 degrees, right? Like John said, like a corner. If their dot product is 0, and the dot product happened to be 0 in this case. So we're going to say that these two vectors here, y'all, are orthogonal. now let's take a look at number 5. We're going to do the exact same thing. We want to know, are they parallel, or they're orthogonal, or it's possible that they're neither, okay? So first thing we're going to do, y'all, we're going to find the dot product of R and S. So negative 6 times 5 plus 15 times negative 2. So the dot product is negative 30 minus another 30. The dot product I'm coming up with is a negative 60. So I know they're not orthogonal because the dot product isn't 0, right? Okay, so then we got to do a little bit of work. We got to find the magnitude of R, and we got to find the magnitude of S, and we're going to multiply those two numbers together, and we're going to compare it with our dot product. So let's first find the magnitude of R. Okay. So first thing I'm going to do here, y'all, negative 6 squared plus 15 squared. And I can do this on my calculator. Let's see, let me turn what's going on here. Negative 6 squared, I already know that's 36. 15 squared should be 225. Add them together. I'm coming up with a square root of 261. Okay, so I'm going to leave that like that because I don't think I can simplify the square root of 261. I don't know, maybe we can. Second square root of our answer. Yeah, it's not a perfect square. So I'll just leave it as the square root of 261. Okay. We got to do the same thing for S, y'all. We got to find the magnitude of S. So let's go ahead and do that over here on the side. So I'm going to say, look, the magnitude of S is equal to the square root of 5 squared plus negative 2 squared. Maybe we can simplify it. I don't know. We'll check in a little bit, John. But for right now, I'm going to leave it as square root of 261 since it's not a perfect square. And I'll explain to you why I'm just leaving it like that at this point. Okay, so let's see. 5 squared is 25. And negative 2 squared is 4. So this is the square root of 29. Okay. So, y'all, the next thing I need to do is I need to take this number here and this number here, multiply them together, and see if what we come up with, okay? So look, I'm going to take my calculator, right, and I'm going to take the square root of, there we go, square root of 261 times the square root of, what is it, 29? And I'm going to multiply those two numbers together, and I'm coming up with nice and pretty 87, right? So the magnitude of R times the magnitude of S gave us, what was it, 87? Yeah, 87 exactly, right? Okay, so now I'm going to compare this number with the dot product, which was all the way over here. Okay, they're not the same, right? They're obviously not the same. Not only are they not the same, but they're not even opposite numbers of each other, okay? So they're going to be neither. They're neither parallel nor orthogonal, right? So this is neither parallel or orthogonal, right? Huh? And you get the same thing, right? But so, John, the main reason I didn't even worry about that is because I was going to use my calculator to do this next part. You know what I mean? But yeah, you can actually simplify the square root of 61 into 3 root 29, but we don't necessarily need to, right? All right, so let me go ahead and scroll down, y'all, so we can get to the next part here. I'm sorry, Johnny, you still copying? You're good? Okay. So let me go ahead and zoom in on this here, y'all, so we can take a closer look to this. And let's see, what do we have here? It says decompose vectors into two orthogonal vectors. Okay, so let me clean up some of this mess just so we can see everything a little bit better. So the decomposition of a vector into orthogonal vectors. So it says if V and W are two non-zero vectors, then the projection of V onto W is given by, and there's a little, like this notation y'all just says, the projection of V onto W is equal to the dot product of V and W divided by the magnitude of W squared times the vector W. Okay, and it says to decompose V into vectors V1 parallel to W and V2 orthogonal to W. V1 is the projection of V onto W, and V2 is V minus V1. So we're going to figure out what all this stuff means and how to apply it with our problem that we got over here. Okay, so let's take a look here. Trying to make sure I got everything. I'm sorry? Okay, so let's take a look here. We got our two vectors V and W, and we want to find the projection of V onto W. Okay, so the first thing we're going to do, y'all, I'm going to write my vectors in component form. So vector V is going to be 3 and what, -1. And W is going to be vector -8 and -3. Okay. All right. So if you take a look up here, y'all, the first thing we're going to do, we're going to find the dot product. So we're going to find the dot product of V and W. Okay. So remember how we find the dot product? We're going to take 3 times -8 plus -1 times -3. So that's going to be a -24 plus 3. That should give me a -21. So the dot product of V and W is, I'm coming up with a -21. Okay. We also need to find the magnitude of W squared. So let's find the magnitude of W squared. So y'all, if the magnitude of W has the square root, but if we square it, we're going to get rid of that square root, right? So wouldn't it just be -8 squared plus -3 squared? Right? So let me write it this way just so we get a better idea. So if this is what the magnitude of W looks like, if we decide to square both sides, then the square and the square root will just cancel each other out, right? Okay, so -8 when I square it is 64. -3 when I square it is 9. 64 and 9 should give me something like 73. Okay. So we found that the magnitude of W squared was equal to 73. And so now what we're going to do is, look, y'all, we have the dot product, which was -21, divided by the magnitude of W squared, which was 73. So I'm going to write this as -21 over 73. And we're going to multiply that times the vector W, which was the -8 and the -3. So this is going to be a vector, y'all. Okay, this is going to be a vector. Okay, so I'm going to go super slow. Remember, all I'm doing here, y'all, is just multiplying these numbers. Okay, so I'm going to take my calculator. Let me move this over to the side. Here we go. So 21 times 8, they're both negative, so I know it's going to become positive. So 21 times 8, probably something like 168. Yes, 168 over, I can think of this 8, y'all, as 8 over 1, so that'll be over 73. And then -21 times -3, that should be something like a positive 63 over 73. John, did you come up, I know you were doing yours on your calculator using the vector features. Did you come up with the same thing as did you get the -21 for the dot product? Yeah. And for the magnitude of W, did you still come up with 73? Or And then we got to square it, so it's the 73? Good. Okay. So just so you guys have an idea of what I'm doing, right here, y'all, this number, the top number is the dot product, and the bottom number is the magnitude of w squared. So I'm writing that as a constant. Okay, I'm just taking those numbers and writing them as a fraction, and then I'm multiplying by each of the components in my vector w. And so I'm thinking of this -8 as -8 over 1, and that -3 is -3 over 1. Okay. So far? Okay, good. Just checking with you. Okay, so look, y'all, part B says find vectors v1 and v2 so that v1 is parallel to w and v2 is orthogonal to w. Okay, so just so we get an idea, how do we do this here? I want y'all to notice something. Right up here at the top, y'all, look what it says. The v1 is the answer that we just found. Okay, so I'm going to come back over here and I'm going to say my vector v1 was the vector 168 over 73 and 63 over 73. Okay, so there's my vector v1. Now we're going to find the vector v2. Okay, so look, I'm going to scroll back up here and we're going to see how do we find our vector v2. So the vector v2, we're going to take the vector v and we're going to subtract the vector, v1. Okay, so look, my vector, we're going to take v minus v1. So notice what my vector v was. We already had it up here. It was 3 and -1. And we're going to subtract the vector v1, which was the 168 over 73 and the 63 over 73. Okay. So remember how we do this, y'all. We're going to do this piece at a time. I'm going to take this number minus that number, and then this number minus that one. So first thing I'm going to do, I'm going to think of this as 3 over 1 minus 168 over 73. Okay, first question, what's my common denominator? 73, right? All right, good. Okay, so let's see, what's 3 times 73? 219. So we're going to go 219 minus 168 all over 73. And let's do 219 minus 168. Okay, 51. So far, my vector v2 has the first component of 51 over 73. Now, we're going to do the same thing for the second part. So we're going to take -1, and I think of that as -1 over 1, minus 63 over 73. Again, we know our common denominator here, y'all, is 73. So that's going to be a minus 73 minus 63 over 73. Okay. Negative 73 minus 63 should be something like negative 136. Boom. And there's my vector. Okay. That's it. That's it. Okay. So, y'all, I'm going to pull something up again over here real quick just so y'all can see. And so who's watching from home? Let's see, we got Thomas and Luciano. Good, I'm glad you guys are here. Okay, so y'all, this was the folder that I put up for this week here. So I'm just going to kind of zoom in here and I'm going to highlight this part just so we can see what's going on here. So let's see. Oops. Look at this. It's the part that I really wanted to focus on. Okay. So y'all, the homework for 7.5 is already open. It opened up today at 2. So there shouldn't be a whole lot of problems in there, okay? And it's going to be very similar to what we did today. Y'all, the review is already open in Alex. I want y'all to start working on that. So next Wednesday, you guys, let me see, I think I have it here. Yeah, here we go. So right here, Wednesday, the 10th, here we go, here it is. On Wednesday, this part. On Wednesday, so 1 week from today, y'all, that's the day that I'm gonna say, okay, what questions do you want to ask me? And just like we did for test one, y'all, I'm gonna put the review up here on the screen, and we're gonna go through one at a time. And you're gonna say, hey, can we do this one? Can we do this one? Can we do this one? Can we do that one? Okay. So we'll go through that next Wednesday. The test, y'all, will start that day at 4 o'clock. Okay. So 4 o'clock. I say 4 o'clock because our class officially ends at 4:15. So we might be here next 15. We might not actually be here till 4:15, but the test will start as early as 4. Okay. And it's going to stay open, so you guys will be able to take it as early as 4 o'clock on Wednesday. It'll be stay open until Monday, the 15th at midnight. So you can take it starting next Wednesday, Thursday, Friday, Saturday, Sunday, all the way through Monday. You can take it whenever you want. I haven't made the test yet, guys. Okay, I'm going to send you guys a message probably Friday on Pronto, letting you know, hey, y'all, I made the test. This is how many questions it's going to have. Just like the way we did test one, y'all, you're going to have the 2 attempts and the second, and it's the quick retake, right? So when you go back the second time, you only got to do the ones that you missed, okay? And then that day, y'all, Monday the 15th, you won't have class. That's me giving you the day to take the test. So if your schedule is full to the point you're working a lot, and I know some of you are, you're taking a bunch of classes and you're like, I just don't have time to do it outside class, then you don't have to take it. You can take it on Monday. You can take it from 2 to 4:15 or 2 to whatever time it takes you, okay? So that's me giving you that day to do that stuff. This coming Monday, y'all, we are going to cover something new. It won't be on the test, but I kind of have to keep moving along a little bit just so we don't take the whole day, okay? On the same token, y'all, Monday, if y'all have questions, let me know. After I go through what we're going to do Monday, you got the cert, can we go over this one? Definitely we can, okay? So, excuse me. So anyway, that's it for us today, y'all. Let me stop